I want to graph it and find the zeros from, actually, can I back up? This is not the one I want to do first. Maybe it is. Yeah, we'll go ahead. We did this one yesterday. So yes, we'll start. Sorry, confusing myself. I want you to graph this on your graphing calculator and see if we can locate the zeros from that. So you're going to go to your y equals, clear out anything that's in there. And we want 2x to the third plus 5x squared minus x minus 6. And let's just hit zoom number 6 so we're all looking at the same thing on our graph. How many zeros would we expect this to have? 2 turning points, but the most zeros it could have would be, the degree tells you how many it can have. Now it doesn't have to have that many, but that's the most. Okay, so if I look at this one, how many zeros does it appear to have? 2. But one of them, you notice your graph hits and bounces off of. So what does that mean? It has a multiplicity of 2 if it bounces. Okay. So how do I find those? Okay. If you want to do that on your y equals, you need to have your y2 set to 0 first. So make sure if you're going to find them exactly, you need to make your y2 0. And then we could do our second trace intersect. First curve enter, second curve enter. Guess if I get close to this first one. It tells me it is at negative 1.5. Why is mine telling me negative 2? Correct. Do we all type in the same equation? 2x cubed plus 5x squared minus x minus 6?
No.
Okay. Oh, did you guys find this one over here first?
I don't know. I don't know. We're supposed to be left on
I got negative 2. You guys really didn't get that? Okay. It's really not an issue. If we zoom in on this graph, it looks like it's bouncing there. It's really not. It went through just slightly. So there are really 2 separate zeros there. So our original window is misleading, which are all points that I'm bringing up in the next section. We're going to talk about how to do this without just graphing it, because when we just looked at that original graph, it was very misleading. And you have to be very cautious of that. So this just goes to show why you can't always trust your graphing calculator, because based on your window, it might look one way when it's really another. These are 2 separate zeros. So it's negative 2, negative 1.5. And let's go ahead and find the last one.
I'm shocked.
So if we do our second trace intersect, first curve inner, second curve inner, guess. This time we're going over to the right. And that one is at positive 1, which we probably could have estimated without doing that, but we don't know for sure that's exactly 1 unless we go through that process. Okay, so we found those. If I asked you to find the solutions to p of x equals 0, what does that mean? I'm asking when the y is 0. Finding the solutions, I'm asking you to find the x values that make y equal 0.
Plugging 0? No.
Well,
You just guess and hope you get it right.
haven't we already done that?
Wait,
I'm asking for the x's that make your y 0.
The same ones as X.
It's the same thing, isn't it? Asking for the zeros is the same as asking when the equation equals 0.
Oh.
Oh.
Okay. So my brain was fried before I came in. Now it's just gone. I literally don't have it.
Today's a struggle. Okay, if I ask you to list the factors. Okay, we talked yesterday about the difference between factors and zeros. Zeros are just a number. The factors are when you put the x with them. So if negative 2 is a 0, what's the factor?
X equals 2. I mean, never mind.
If negative 1.5 is a 0, what's the factor? If 1 is a 0, x minus 1. Good. Write the factored form.
Is that just,
Wouldn't it just be the
P of
same
X
thing smushed
equals
together?
5?
Just another way of asking the same question.
They're trying to help you guys.
It's working.
Yes.
Doing a good job of it today.
This is so...
It's so much. We've only done one thing.
No, but everything this week is just too much. Yeah,
We're not final and
I don't think it's going to be your
Okay, let's look at our graph. I want to know when p of x is greater than 0. So if I look, where is this graph above the x-axis?
Negative 2.5 to, no, just kidding, negative 2 to 1.5. You get what I'm saying.
Is it above the x-axis anywhere else?
Yeah, 1 to infinity.
Mhm.
Would you put brackets there if it was equal to?
Yes, if I had an equal to, then you would. Alright, if I asked when p of x is less than 0,
Negative infinity to negative 2. Negative 1.5 to 1. That's it. That's pretty good though.
it's just asking when our graph was below the x-axis.
And if that's a greater or equal to, then we put brackets.
Yes, that is correct. Okay, questions? So, we're going to keep moving on with this. But what we're finding is the graphing calculator, it's very helpful, but it's not perfect at finding the zeros. We have to adjust our window to know what we're looking at, so we have to be a little bit careful with that. What we are going to be doing today, and this is really for the rest of the day, we are going to find all the zeros of a graph. So those are the x-intercepts. But I am giving you a starting point. I am going to tell you one of the zeros. And we are going to find all the others without our graphing calculator from that information. Okay? So, on this one. If I give you the first 0, if it's a 0, what does that mean?
It's just the x-axis.
It hits the x-axis there. It makes it equal 0. It divides evenly. Didn't we learn how to do synthetic division yesterday? Okay, we are going to do synthetic division with this number. So my 5 goes out here, and then I put my coefficients. Okay. Remember the first thing, what happens?
Comes down.
Yep, 6 comes all the way down. Then we multiply and add. 6 times 5 is 30. Add -7. Multiply -35. Add -3. Multiply -15. Add and we get 0. Okay. If I wrote my quotient, remember this is my remainder, my constant, x and x squared. We have 6x squared minus 7x minus 3. But this is a quadratic. Don't we know how to solve quadratics? Quadratic formula. Let's try box method first and see if it works. If not, do the quadratic formula. So those multiply to -18. Add to -7. What would that be? -9, +2. So factor, we get 3x and 1. 2x minus 3. Okay. My directions were to factor this. So I want the x's. Since it was an x cubed, that tells me I'm probably going to have 3 parentheses. I have 2. What is my third one going to be?
X plus 5.
Close.
That's minus
X minus 5. So this is the factored form of our polynomial. Questions?
I have a question.
Uh-huh.
Is our final going to be over everything that we've learned this semester?
Why don't you guys try this one? Make sure if you have any missing powers of x, you put in zeros for them. Comes down, multiply -18, add 1, -3, -1, 3, 0. So that's 6x squared plus x minus 1. Did you guys get that part? We can do box method here. These multiply to -6, add to +1.
-2 and 3.
Yes. Factor, so we get 2x, 1, 3x minus 1. So, to this point, I have my polynomial is 2x plus 1, 3x minus 1, and what else do I have?
X plus 3.
Right, because -3 was a 0.
Wait, can you
That's
do
my
that
factor.
using the quadratic?
When you get to the 6x squared plus x minus 1? Yes.
No, because I did it and I got -23 under the wrap.
You made a mistake.
What's new?
You want me to look at it?
I didn't do it like that.
Oh.
I erased it because I knew it was wrong. But
Did you have a question? Okay. Let's look at a similar problem. But I'm going to switch your directions. This time I'm not asking for the factored form. I'm asking the remaining zeros. Okay, but we know the difference is when I ask for the factors, that has the x with it. When I ask for the zeros, those are just numbers. So we are going to do this the exact same way. The only difference is how we answer the final question. So I start with my 3. One comes down. Multiply, we get 3. Add gives us 2. Multiply, we 6. Add and we get 2. 6 and 0. So we get x squared plus 2x plus 2. Alright, 1x squared, we could do the shortcut. Does anything multiply to 2 and add to 2?
No.
No, so we could do shortcut, but it doesn't work. So what do? Quadratic formula. So x equals opposite of b, so -2, plus and minus the square root of b squared minus 4ac all over 2a. Okay. -2 divided by 2 is -1. What's the square root of -4? 2i divided by 2 is I.
Okay, and then I'm just plugging the thing underneath the radical. I got it 0. So, do you have the whole thing in parentheses?
Are you trying to do it in your calculator?
Yeah, and I just keep getting it wrong.
Well, this one is type 4a.
Yes.
Your C is 2.
Oh. But,
And I
And
understand.
then, yeah, then you get an -4. It's really.
I understand.
Okay. The question. If I asked for the factored form, you would have to do x minus 1 minus I and x minus the 1 plus I. I asked for the remaining zeros. Now, because it's x cubed, I expect 3 zeros. I gave you one of them already. So the remaining ones, the other two, -1 plus I and -1 minus I. So that is our answer. Because I just asked for the zeros, you don't have to put the x's with it. Yeah, it's imaginary. We couldn't graph it, but
Do you want us to rewrite the theorem that you gave us?
if I said all the zeros, yes. If I say the remaining, no. Other questions?
And do we have to put like columns separately?
If you wrote them separately, yeah. Okay. Let's do another one. Do you guys want to try one? You do this one. All right. So start with our synthetic with 2. Are you guys doing pretty well with this synthetic?
Yeah.
Yeah.
So this is 2x squared plus x minus 15. Some of you did quadratic formula, which is fine. This one also is factorable by box method, so either way is great. Those multiply to -30, add to +1, so you could do 6 and -5. So factor, you get 2x minus 5, x plus 3. Okay. If I asked you for the factored form, you would put your x minus 2 with this and be done. I asked you for the remaining zeros. So what you have to do is set each of those equal to 0. So add your 5 divided by 2. You get 5 halves. This one is x plus 3 equals 0. Subtract your 3. You get negative. Yes.
Okay, whenever you ask for the remaining
Mhm.
zeros or whatever, what if you do the quadratic, because then you don't get 2x
If you-
minus.
You get, like when you did the quadratic, you got, what was it, like,
-1 plus minus 11 divided.
so if you simplify, -1 plus 11 would be 10 over 4 is 5 halves. -1 minus 11 is -12 divided by 4 is -3, so you get the same
So
thing.
then you would just have that instead of 2x minus 5, x plus 2.
Yeah,
When I put that in, I got 1.75 and -3.
you didn't put parentheses around the top.
I just didn't tell them the answer.
Okay, other questions? I want to do one more problem and then I'm done. We're just gonna do probably just one of these. I've got a couple, but we'll just do one. Okay. It's fairly ugly. Got all these eyes in it. But I gave you a 0. I told you that 3i was a 0. So where do you begin?
You don't.
Oh, you do.
I'm with her.
Synthetic with the 3i. Okay. Your coefficients. We have a 1 in front of the x cubed. We have 7 minus 3i in front of the x squared. 12 minus 21i in front of the x. And they have 36i for the constant. That turned out really pretty. Promise. So 1 comes down. 1 times 3i is 3i. What happens when you add? You get 7. 7 times 3i is 21i. Add, you get 12. 12 times 3i is 36i. Add, and we get 0.
They always gonna be like that? What?
No. No. She's just trying to be nice right now.
Yes, Kinsey.
Oh, never mind, I figured it out. You
Okay.
just cancel them out.
Yep, we're just adding. So this gives us x squared plus 7x plus 12, which we can factor nicely. That gives us x plus,
3.
okay, what did my directions ask for? The factored form. What else do I need with this?
That's what.
Good. If I asked for it, what are the zeros?
-4, -3, and 3i.
If I asked for all the zeros, you could certainly get them too. Alright, are we okay with this stuff? Yes.
Is there gonna be any on our homework that don't work out nice like that?
No, this assignment I don't think it has any eyes on it. Tomorrow, we are going to have a quiz over sections 1 and 2. So section 1 is basically looking at your in behavior, maximums and minimums, knowing the difference between a local and a global maximum and minimum. And then 4.2 is all of this stuff. We will do a little bit of review at the beginning of class tomorrow. I'll probably put a few problems up when you come in for you to try and go over those, and then we'll take our quiz. So yesterday's Math Excel is due at the end of the day today, so if you have questions on that, let me know. This one is open and due at the end of the day tomorrow.